Hi, this is Sam Urison from iQuest. In this video, I'm going to talk about Azure DocumentDB and the journey from SQL to NoSQL, or in other words, from a relational database to a document database. With that said, let's start by talking about what a document database is. A document is a JSON object, as you can see on the screen. And we call these JSON objects documents within the context of document databases. So with that said, a document database is a database that stores data in documents, in these JSON objects. Simple as that. Furthermore, document databases will index properties of our JSON objects or these documents so that we can run queries against them. Especially in the case of Azure DocumentDB, if I were to save this particular document in my database, I can run queries against any one of those properties because DocumentDB will index all of those properties automatically. Now, I have the ability to fine-tune that. I can say, for example, I don't think I'm ever going to run a query against the project status, so don't index it. So I can do that. But if I didn't do anything and I use the service as it is out of the box, DocumentDB will index every single property. So I can say I'm looking for a client whose phone number is 206-555-9999, and I will get this particular document. It will do that automatically, and it will do it instantly. That's a very, very powerful feature in DocumentDB. Because if you're coming from a relational database background, you're kind of used to worrying about your indexes so that you can kind of optimize the performance of the database. But in the case of DocumentDB, it's completely automatic. Next, I want to look at some of the basic concepts, and I think it may be a good idea to do kind of side-by-side, apples-to-apples comparisons. In some cases, I'm going to talk about differences. In some cases, I'm going to talk about terminology. And also, I'm going to kind of switch back and forth between my slides and an actual relational database and an actual document DB database so that we can see, and I'm using the same exact scenario in both cases so we can see exactly what it looks like in a relational database and what it looks like in a document database. With that said, the first thing that I want to talk about is normalization, or lack thereof in the case of DocumentDB. This was very strange for me in the beginning. Why? Because of all the programming of my mind, because I've been using relational databases for so many years, and we've been told again and again to normalize our data in relational databases. That's something we do. And in DocumentDB or document databases in general, we do not normalize our data. Now, what does that mean? Let's kind of take a look at this. So here's our example. So what I'm doing here, just to give you the scenario a little bit, this is basically a company, a management company that has clients, and the company is basically managing the client's projects. And each client can have multiple projects, and each project will have one or more project managers assigned to it. So that's the scenario. With that said, the first thing you'll notice is that I have 4 tables. Again, this is a very simple example. I wanted to keep it simple. So clients, employees, projects, and project teams tables. So if I were to look at my employees table, for example, and the data in it, I can just run this simple select statement. And as you can see, it's a very simple table: ID, first name, last name, and gender. And if I were to do the same thing with the clients table, again, a very simple table with very simple data in it. Now, when we get to projects, we kind of start to see some of the, I don't want to call it a shortcoming yet necessarily, because this is just the way you do things in a relational database. But in this select statement, I get all my projects in the database, but just by looking at this, I have no idea who this project belongs to, who the client is. It's got this strange looking ID number, it's EC121967, and I have no idea who that is. Why? Because my select statement is a very simple select statement. It just goes against a single table, and it doesn't tell me who the client is. Why? Because the database is normalized. I'm not going to repeat the same data. I'm not going to duplicate my data in multiple tables. The client name or client phone number or website belongs in the client's table. And anytime I need to make a reference to that particular client, I'm going to use its ID, which is exactly what I did here in the projects table. Again, if you're coming from a relational database background, you'll look at me and say, of course, that's what you do. What's so strange about it? And if I need more information about this, I simply create a slightly more elaborate select statement, like in this case, by having a single join. Now I can get the client name. This doesn't look very tidy, so maybe I can tidy it up a little bit more. There you go. This looks much more manageable now. I can see both the project information as well as the client information. But this is still not a complete picture. I still don't have any idea who's managing, for example, this particular the project. So if I want to go to the next level, I can create something slightly more elaborate, and then here it is. So in this case, I can see the project name, client name, even the manager's name. And this is what we mean by normalizing data. We're not going to duplicate the data. And just because we didn't duplicate it by using a single table, we were not able to get all the data that we need. So we needed to include other tables in our select statement, which required joins. And in the case of document databases, we do not normalize our data. So what does this look like in a DocumentDB database? So the first thing that we're noticing here right away is that we don't have these tables. Here's our test DB, and we have this thing, let's call it a container to keep it simple, this single container called main collection. Why is it called main collection? Because I named it main collection. I could have named it Sam's collection. I could have named it XYZ1. Who cares? Of course, you want it to be something meaningful. And if I click my main collection, I see that there are 4 records in there. Actually, 4 documents, right? We want to use the right terminology. So if we were to click this first one, here's the client document. And interestingly, I see all kinds of information in there. In one document, in one JSON object, I have everything I need. I know the client's name. I know the client's phone number. I know the client's website. But I also know the client's projects. I even know who is in the project team, who's managing those projects. Everything is in one place. So this is what I mean by denormalized data in the case of document databases. In relational databases, we normalize data by creating multiple tables and then creating relationships among those tables. So the next point is a related one. In the case of relational databases, we also have this concept of enforcing referential integrity. That sounds pretty fancy. What we mean by that is that, again, if we were to switch back, here's my clients table, and I have a client ID. We've already seen it. And then if I were to open up the projects table, you'll notice that I have the client ID, and it's set up as a foreign key. It's basically pointing back to the client's table. What it's saying that the value in that column, in the projects table, must exist in the client ID column in the clients table. So what happens if I try to put some ID in there that I just made up that doesn't exist in the clients table? It's not gonna happen. Not with this design, because I'm asking the database to enforce referential integrity. In this case, the database is going to give me an error. It's going to say the ID that you're trying to use in the client ID column doesn't exist in the clients table, so you cannot enter it. Another example is maybe there's a client that I know we're not going to work with anymore, so I want to go ahead and delete that client's record from the clients table. But let's say the client has multiple projects in the projects table. Again, my database is going to come back and say you cannot delete that record because you have some other records in the projects table that are pointing to that. It's not going to let me end up with what they call orphan records, where I may have a project or two and I have no idea who the project belongs to. I don't have the slightest clue who the client is, right? So that's what we mean by enforcing referential integrity. So back to our slide, we're saying DocumentDB does not enforce referential integrity. So you may say, wait a second, this really is a recipe for disaster because we're duplicating data all over the place and nobody's enforcing any kind of integrity in this database. So what's going to happen? So let's look at the actual example. In the client document, we have the client's phone number, which makes perfect sense. The phone number belongs to the client. That's where it belongs. But in the next document, I have a project for the same client. And even though this is a project document, I know because the type is project, I have client's name and phone number. So I duplicated the data in two places. So this could be a really big problem if the client changed its phone number and I forgot to update the phone number in both places, both in the client document and the project document. So if the database is not going to do it, the question is who's going to do it? And the answer is you. Now that responsibility falls on you. And we're going to talk about this a little bit more later, but just to give you a quick idea about how to handle it is that you handle this in your application. So if one piece of information changes, like I said, in this case, the phone number changed, now you have to have the logic in your application to go find all the projects that belong to that client and update the phone number one by one. Now you may say, wait a second, this is very inefficient. And it makes no sense to use document databases. And let me prove to you that it makes perfect sense. But before I do get into that, I want to tell you something. You may say, wait a second, I have an application that's pretty demanding. It's an enterprise application or it's an e-commerce website that uses a relational database as the backend, and it's perfectly fine. And you're right. Relational databases have been around for a long, long time. They're very stable, and they're very efficient these days. So chances are if you're running a typical application, you don't need a document database. But if you're dealing with a very popular, let's say, website, let's say an e-commerce website, that needs to support millions and millions and millions of simultaneous concurrent users, you're going to run into performance issues with a relational database for sure. So those are the cases when you need to look into technologies like NoSQL databases. But the example that I want to show you is the next select statement. So if I wanted to see the big picture, I don't want to see just the project name and the client name, but I also want to know who's managing these projects. So here's my select statement. Now, please keep in mind this is a very simple database, very simple tables, and very, very simple data in them. And look at the select statement I needed to create to be able to see the big picture. This select statement already taps into 4 different tables, and it has 3 joins. So in a real-life scenario, it is not uncommon to create these complex select statements with many, many joins in them, and that's precisely where the problem is, because these joins are costly in terms of performance. Every time you join a table to another in your select statement or your sort procedure, you're taking a performance hit, that's for sure. Now, it may not be noticeable in your application, but it's there. There's no way that the performance you're going to get by running a select statement that pulls its data from a single table versus a select statement that pulls data from multiple tables using multiple joins, there is a big performance difference. It's very easy to test it, actually. You can create something and run it, say, 100,000 times or 1,000,000 times, and you'll see the big performance difference. So what document databases try to solve is this. And so if you don't have a need for it, then you don't have a need for a document database. If your application is perfectly happy with its relational database in the back end, by the way, it can be anything. It can be MySQL or Microsoft SQL Server, Oracle. They're all fine. Some people get into arguments about which is better. For most applications, it doesn't make any difference. They're all perfectly fine and reliable. But so this is the problem that we're trying to solve. In the case of a relational database, I had to create this somewhat complex select statement with multiple joins, but I can pull the same exact information if I was storing my data in a document database from a single JSON object. Everything I need is in one place. But as I mentioned, if the data changes, such as the phone number, then it's going to be my responsibility to actually update multiple documents. We've already kind of seen this already in our examples. In the case of the document database, DocumentDb, I have a single collection, and as you can see, I'm storing a client document in there, as well as a project, as well as a manager. In the case of a relational database, I had to actually create multiple tables, and each table basically has uniform data. Basically, I'm saying that in the employees table, you'll never find project information. In the clients table, you'll never have employee information. Each table has uniform data in it. But in the case of these documents or JSON objects, as you can see, even though I'm looking at a client document, I have project information in it. In this case, I'm looking at a project document, but I still have client information in it. The next point is flexible schema versus a schema that is set. In the case of relational databases, obviously, when we created this table, that's the schema. We decided that, in this case, I decided there's going to be an ID column, then project name, client name. I'm sorry, this is not the select statement with the joins, but here's the projects table, ID, client ID, project name, and status. That's it. Now, this is not cast in stone. I can change it, right? I can modify it. Yes, I can. But if that table has millions of records in it, and if your application happens to be a demanding application that is mission critical, it's not a lot of fun to update the schema of your tables. In relational databases, you may have to take down the database for a certain period as you make those changes. In the case of document databases, Azure DocumentDB in this case, as you can see, I'm mixing things up all day long. I have a client object and a project document and a manager document all in one collection, and the database is perfectly happy with it. So this is what we mean by flexible schema. Furthermore, if you look at this third one that we're looking at, this is a manager document, and then the fourth one, which is also a manager document, you'll notice, once I point out, that this one has a client website property. But if I go back, this is the document for James Green. If I go back to Jane Doe's manager document, you'll notice that the client website property just doesn't exist. So when I say flexible schema, I don't just mean different types of documents, but I also mean even different versions of the same document. So here's a manager document, and here's another manager document, and one has an additional property, and that's perfectly fine. I didn't have to go back. Just because I added this client website property, I didn't have to go back and update every single manager document in the database. I can have two versions side by side, and the database, again, is perfectly happy. It's a major difference between a relational database and a document database. Next is how we interact with our databases. Obviously, in the case of relational databases, we have the SQL language, the structured query language that we've been using for decades. And in the case of Azure DocumentDB, Microsoft has done a pretty good job coming up with an SQL-like language. It's not SQL, but it looks like it. So transitioning from SQL to this new language is pretty easy. But on top of that, Microsoft included JavaScript so that we can actually manipulate our data. For example, in Azure DocumentDB, we can create stored procedures that we can literally save in our collections that can manipulate our data. So one example is, for example, in this case, right, we said what happens if the client changes the phone number. So we may choose, maybe I'm going to manage that through a stored procedure in my collection. I'm not going to use my application. So I'll keep the whole thing in the database. So in that case, I can create a stored procedure that's going to update the phone number. And That's a single hit. I call that stored procedure, and that stored procedure will go find the client, update the phone number, then go find all the corresponding project documents for that client and update each and every project document and update the phone number one by one in a single hit, in a single call to the database. So that's how we deal with manipulating data or interacting with our databases in the case of DocumentDB. As we continue, this particular item actually is only applicable to Azure DocumentDB. It's a service. It is not something that you can download and install and run on a server. If you're coming from relational databases, you're used to running your database in physical or virtual servers, not DocumentDB. But having said that, as you can see, I've been using this DocumentDB emulator. That's something that I downloaded. Again, I would never use this in a production environment. It's something that Microsoft created for developers, but I'm using this locally. But having said that, if I wanted to use a real DocumentDB database in a production environment, it's a service. It runs on Azure only. That's a major difference. Next item is more like a terminology reference. We talked about it. Basically, the containers that we use to store data in DocumentDB are called collections, as opposed to tables in the relational database scenario. And one caution, this is something that I did unintentionally, but as I was transitioning from relational databases to DocumentDB, I was creating multiple collections and I was trying to use them as tables. So that may be a common tendency. Don't do that. Collections are basically very robust. You can have multiple types of data in them without any problems whatsoever. Next one also is another terminology reference. A single unit of data in a collection is called a document. Again, we talked about it. It's a simple JSON object, but we call them documents. And of course, they're called records or rows in the case of relational databases. Now, Azure DocumentDB is not the only document database. There are many of them. If I'm not mistaken, MongoDB is probably the most popular these days in terms of number of users. And there are others, CouchDB, RavenDB. Amazon SimpleDB is actually very comparable, very similar to DocumentDB because it is also a service. It runs as a service on Amazon's AWS cloud platform. Now, this brings me to my point, to the next point, which is why I chose DocumentDB, why I actually picked it. I like it. Now, with that said, it's a personal thing. I'll give you my reasons. You may agree or disagree with them, but these are my reasons why I like DocumentDB a lot, and that's why I picked it. Again, also keep in mind that I have the responsibility of building a very scalable application. The application that I'm architecting actually requires a highly scalable and super responsive database as its backend. And so I was in a situation where I could not just use a simple relational database. So just wanted to kind of disclose that. With that said, the first thing is it's a service, and I love services. Why? Because I don't have to worry about any of the underlying technologies, such as the operating system or the database upgrades or hot fixes or security fixes. I mean, who wants to worry about those things? I am not in the business of developing or maintaining operating systems. I have my own application. That's what I want to worry about. And my application requires a database, so that's what I need. I just need database functionality. I don't want to worry about optimizing that database. I don't want to worry about updating firmware on servers. I don't want to worry about updating the database, anything like that. So in my case, that's the reason why I love services, and Azure DocumentDB happens to be a service. Second, it's a metered service, so I only pay for what I use. That's, again, wonderful. If you have a server, it doesn't matter if that server is sitting there idle, you're paying for it. If you have a virtual machine, again, you're paying for it, whether you use it or not. In the case of Azure DocumentDB, it's metered, so you only pay for what you use. But I have to mention that it's not cheap. If you look at price comparisons, Azure DocumentDB is actually more expensive than Azure SQL database. So keep that in mind. But why do you use a DocumentDB in the first place? We talked about it. If you need hyper scalability and hyper performance, you need something like DocumentDB or some other document database. And in that case, that additional premium that you pay is justifiable. Next is high performance. Read times less than 10 milliseconds. In my personal experience, I'm looking at 5, 6, 7 milliseconds, and that's pretty good. Why? Because in that 5, 6, 7 milliseconds, I got everything I needed. I pulled a JSON object that contains everything I need. So it's not like I have to worry about joins and things like that. I hit the database once, I pulled a single JSON object, and I have everything I need. And I got that in about 5, 6, or 7 milliseconds. That's pretty good. Of course, what we need to keep in mind, though, that makes the assumption, this statement that I just made, 5, 6, 7 millisecond response time statement makes the assumption that your application is pretty close to your database. If you have your application running on a server in New York City and your DocumentDB is running in a data center, Microsoft data center on the West Coast in California somewhere, I don't know, maybe Redmond, Washington, you're not going to get that level of performance because you're introducing the latency caused by the internet. Just going across the country is going to add some additional time to your call. So this statement makes the assumption that you're keeping your application pretty close to your actual database. Next is super scalable. I mean, there's really no technical limit. You can really keep on going. I think you get 10 gigabytes of space, actual storage space in your DocumentDB to begin with, and you can keep adding more to it, and there's no limit. And the best part about it, again, because it's a service, I don't have to worry about how to actually provision new resources. It's just there. When I need it, it's there. Next is an interesting one, and it's kind of a new announcement from Microsoft. Now, DocumentDB supports MongoDB protocols. I heard that some people were actually able to take their MongoDB databases and migrate them to DocumentDB without changing a single thing, and it worked. Again, MongoDB is a very good document database to begin with. So you may say, why do I need to even migrate my database to DocumentDB? Maybe you don't. If you're happy with MongoDB, why would you? I also heard that now some companies actually provide MongoDB as a service. So there you go. You're getting the same benefits as Azure DocumentDB. Next one is really my absolute favorite as a developer. I save my POCO objects directly in the database without any kind of mapping. I mean, this is heaven. I have a customer object that I use in my application to, deal with the logic or, interacting with the user maybe. Then I take that object without changing a thing. I save it in my database, and then I can run queries against it instantly. This is absolutely wonderful. If you have a relational database in the back end, and if you're dealing with objects in your application, of course, you have to kind of use some kind of middleware, right? You have things like Entity Framework or other mapping technologies to be able to kind of map your objects to your relational tables. But in this case, there's an inherent loss in that process, right? If you're converting something from one thing to the next, it may be super fast, and you may never notice it if you don't have, like I said, a web application that supports millions of simultaneous users. You may never notice it, but it's there. And so just this is actually one of my favorite features. I don't have to worry about converting anything. I just save my object directly. Then you may come back and say, okay, this sounds all wonderful. Should I go ahead and unplug my relational database? And the answer is, I don't think so. I don't think relational databases are going anywhere anytime soon, if ever. So with that said, what's going to happen? I'd like to introduce this concept It sounds pretty fancy, but it's a simple concept. Polyglot persistence. What that means is that applications should talk to multiple types of databases, utilizing each for what it's best at delivering. Again, when I say applications, I don't mean your typical enterprise application that supports hundreds or even thousands of users. I'm talking about applications that need to scale up to millions and millions of simultaneous users. In those cases, what you're doing is you have your application, and it is communicating with multiple types of databases in the back end. So you're making some decisions as far as which database you want to use for the kind of data that you want to save on it. So, for example, if we're dealing with an e-commerce website, you have products and you have customers, it may make perfect sense for you to store customer and product information, product data, say in a DocumentDB database. Why? Because you save these nice and rich JSON objects, and when you need them, you just pull the whole thing in a very simple and efficient call to the database. So it makes perfect sense to use DocumentDB or some other document database for those scenarios. But you may say that maybe you're going to store user comments or user ratings in a relational database because you want to make sure that you don't want to make multiple updates in the case of, you want to make sure that the same user cannot rate the same product more than once. So data consistency is very important, and in that case, you wouldn't even need too many joins, maybe one, maybe no joins at all. So in that case, you'll find that the relational database is going to do a perfectly fine job, both in terms of consistency and performance. It's going to be just as high performance as a NoSQL database. So you may say, you know what, it may make more sense for me to store, like I said, user comments or user ratings in a relational database. You may have another one, a key value store. You may have a fourth one, a graph database, for example. And this is what we mean by polyglot persistence. And I think more and more you'll notice that a lot of the really high-end applications that support users in the millions levels are actually going in this direction. They're actually having multiple types of databases in their backends. So this is really this presentation is about. Hopefully you find the data that I presented to you useful. I tried to show you what a particular scenario with we looked at a company, a management company that manages clients' projects, what that database might look like in a relational database, and what the same thing may look like in, say, Azure DocumentDB. And I also tried to share with you some of the issues that I ran into personally as I was transitioning from the world of relational databases and to document databases, in particular Azure DocumentDB. Again, it was not necessarily a challenge from a technology standpoint. I learned the technology fairly quickly. It was more of a challenge of changing my mindset or changing my habits. And you may run into some of the same issues. So I hope that you find my experiences and the information that I shared with you useful. Again, thank you very much for watching this video.